Entity Relationship Model. Hello students, welcome to the lecture on Entity Relationship Model, and after this lecture we will be able to learn the following objectives. Understand the concept of entity relationship, discuss about the entity set, describe the mapping constraints, understand the concept of keys and explain briefly the entity and attributes. Entity relationship. Let me first tell you about the entity relationship model in brief. The entity relationship model adopts the more natural view that the real world consists of entities and relationships. A data model called the entity relationship model is proposed. This model incorporates some of the important semantic information about the real world. The entity relationship model can be used as a basic for unification of different views of data, network model, relational model, and the entity set model. The network model is a database model conceived as a flexible way of representing objects and their relationship. Entities are the principal data object about which information is to be collected. Entities are usually recognizable concepts, either concrete or abstract, such as person, places, things, or events which have relevance to the database. Example. Some specific examples of entities are employees, project, and invoices. Attributes describe the entity of which they are associated. A particular instance of an attribute is a value. Example, customer ID, first name, surname, date of birth, address, phone number are the values of the attribute name. The domain of an attribute is a collection of all possible values an attribute can have. The domain of name is a character string. Simple. Attribute that is not divisible. Example, age. Composite. Attribute composed of several simple attributes. Example, address, house number, street, district. Multiple. Attribute with a set of possible values for the same entity. Example, phone, home, mobile, etc. or email. Key. Uniquely IDs the entity. Example, PPSN, chassis number, value set or domain. Each simple attribute associated with a VS that may be assigned to that attribute for each individual entity. Example, age is equal to integer range. Should address be an attribute of employees or entity related to employees? Depends upon how we want to use address information and the semantics of the data. If we have several addresses per employee, address must be an entity, since attributes cannot be set value. If the structure, city, street, etc. is important, address must be modeled as an entity, since the attribute values are atomic. The data that we want to keep about each entity within an entity type is contained in attributes. An attribute is some quality about the entities that we are interested in and want to hold on the database. Associative entities, also known as intersection entities, are entities used to associate two or more entities in order to reconcile a many-to-many relationship. Subtypes entities are used in generalization hierarchies to represent a subset of instances of their parent entity called the supertype. Existent denotes whether the existence of an entity instance is dependent upon the existence of another related entity instance. The existence of an entity in a relationship is denied as either mandatory or optional. Example. An example of mandatory existence is the statement, every project must be managed by a single department. If the instance of the entity is not required, it is optional. An example of optional existence is the statement, employees may be assigned to work on projects. An entity set is a logical container for instances of an entity type and instances of any type derived from that entity type. For information about derived types, the relationship between an entity set is analogous to the relationship between a row and table in a relationship database. Basically, an entity set is defined within an entity container, which is a logical grouping of entity sets and association sets. For an entity type instance to exist in an entity set, the following must be true. The type of the instance is either the same as the entity type on which the entity set is based, or the type of the instance is a subtype of the entity type. The entity key for the instance is unique within the entity set. The instance does not exist in any other entity set. There are some important definitions which you have to study further. ER modeling is a graphical approach to database design. It uses entity or relationship to represent real-world objects. The entity set which does not have sufficient attributes to form a primary key is called as weak entity set. An entity set that has a primary key is called as strong entity. A member of a strong entity set is called dominant entity. A member of weak entity set is called a subordinate entity. The relationship between weak entity and strong entity set is called as identifying relationship. Relationship sets. There are three relationship types. One-to-one relationship. One-to-one relationship have one specific for both cardinalities and do not seem to arise very often. To illustrate a one-to-one, we require very specific business rule. Example, suppose we have people and vehicles. Assume that we are only concerned with the current driver of a vehicle and that we are only concerned with the current driver and that we are only concerned with the current vehicle that a driver is operating. Then we have a one-to-one relationship between vehicle and person. One-to-many relationship. This type of relationship has one and specific for cardinalities and is very common in database design. Example, suppose we have customers and orders and the business rule. An order is related to one customer. Customer can have any number, 0 or more of orders. We say there is a one-to-many relationship between customer and order. Many-to-many relationship. Many-to-many relationship have many specified for both cardinalities and are also very common. Example, suppose we are interested in courses and students and the fact that students register for the courses. Any student may take several courses. A course may be taken by several students. The situation is represented with a many-to-many relationship between course and student. A relationship set is a collection of relationships all belonging to one relationship type. In the set are instances of relationship. For instance, if a relationship type is registration, then each enrollment of a student in a course is an instance of registration and appears in relationship set. A relationship is one instance in a relationship set. A relationship set is a set of relationships of the same type. Mapping constraints. An ER scheme may define certain constraints to which the contents of a database must conform. Express the number of entities to which another entity can be associated via a relationship. For binary relationship set between entity set A and B, the mapping entity relationship model cardinality must be one of one-to-one. An entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in A. One-to-many. An entity in A is associated with any number in B. An entity in B is associated with at most one entity in A. Many-to-one. An entity in A is associated with at most one entity in B. An entity in B is associated with any number in A. Many-to-many. Entities in A and B are associated with any number from each other. If the existence of entity X depends on the existence of entity Y, then X is said to be existent dependent on Y, or we can say that Y is the dominant entity and X is a subordinate entity. For example, consider account and transaction entity set and a relationship log between them. This is one-to-many from account to transaction. If an account entity is deleted, its associated transaction entities must also be deleted. This account is dominant and transaction is subordinate. Keys. A superkey is a set of one or more attributes which taken collectively allow us to identify uniquely an entity in the entity set. For example, in the entity set customer name, and S number is a superkey. A superkey may contain extraneous attributes, and we are often interested in the small superkey. A superkey for which no subset is a superkey is called a candidate key. In the example above, S number is a candidate key as it is minimal and uniquely identifies a customer entity. A primary key is a candidate key. There may be more than one chosen by the DB designed to identify entities in an entity set. An entity set that does not possess sufficient attributes to form a primary key is called a weak entity set. One that does have a primary key is called a strong entity set. The attributes of a relationship set are the attributes that comprise the primary key of the entity set involved in the relationship set. For example, S number is the primary key of customer and account number is the primary key of account. The attributes of the relationship set cascade are then account number as number. This is enough information to enable us to relate an account to a person. If the relationship has descriptive attributes, those are also included in its attribute set. Weak entity. A weak entity is an entity that cannot be uniquely identified by its attributes alone. Therefore, it must use a foreign key in conjunction with its attributes to create a primary key. The foreign key is typically a primary key of an entity it is related to. In entity relationship diagrams, a weak entity set is indicated by a bold rectangle. The entity connected by a bold type arrow to a bold diamond, the relationship. This type of relationship is called an identifying relationship, and in IDEFIX notation, it is represented by an oval entity rather than a square entity for base tables. A weak entity does not have any items in its primary key other than its inherited primary key and its sequence number. An associate entity is an element of the entity relationship model. The database relational model does not offer direct support to many-to-many relationship, even though such relationships happen frequently in normal usage. The solution to this problem is the creation of another table to hold the necessary information for this relationship. This new table is called an associative entity. The supertype entity inherits its attributes to subtype entities based on the value of the discriminator. An entity type defines a collection or set of entities that have the same attributes. Entities are the instances of people, places, things, or events that are of interest. Individual entities are grouped into sets that are similar to one another. Entity types are named after the entities that belong to the set of interest. It is a common convention that the names of entity types are singular and that at least the first letter is capitalized. Example: an entity type named invoice defines a collection of invoice entities. An entity type named invoice line defines a collection of invoice line entities. An entity type named product defines a collection of product entities. When we want to include a certain set of entities in our entity relationship model, we define an entity type to represent that set. Humans can easily perceive entities and their characteristics in the real world and represent any relationship to each other. The objective of modeling graphically is even more profound than simply representing these entities and relationship. An entity is a thing or an object in the real world that is distinguishable from all other objects. Example: in our faculty course student. Example: faculty, students, and courses are entities. An entity has a set of properties or attributes. For example, student has several attributes like SSN, name, address, state, zip, etc. One or more attributes may uniquely identify an entity. For faculty and student, SSN uniquely identifies one particular person. In the real world, entities have some relationship. For example, faculty teaches courses or student takes courses. Therefore, we can model the real world in terms of entity relationship. In order to do that, we represent entities as rectangles, relationship as diamonds, and attributes as ovals. For every relationship, we must consider the degree of relationship one-to-one, one-to-many, many-to-many, called the cardinality. The cardinality describes how an instance of an entity, that is, if student is an entity, a particular student, John Doe, is an instance of the entity student. Think of this as a recorded student table. It's linked to the instances record of another entity or maybe the same entity. The table structure depends on the relationship degree. One-to-one relationship, example, a faculty can teach at most one section each semester and a section can be taught by at most one faculty. Entities in one-to-one relationship can be combined into one large table with attributes from both the entities. The primary key of this table can be any one of the unique keys of faculty and section entities. In some situation, it is better to create two tables, in which case each entity becomes a table with a primary key underlying attribute. Key of either entity can appear in the other entity's table as a foreign key. Let us take an example first to illustrate this concept. A faculty can teach at most 3 sections each semester, while a section can be taught by at most one faculty. Note, a faculty can teach up to 3 sections, so the relationship is one-to-many. That is, one faculty can teach many sections. The same table as in one-to-one relationship hold good, but here there is no ambiguity in terms of which primary key of a table should go into the order table as a foreign key. Understand this concept by an example. A faculty can teach at most 3 sections, while each section can be taught by at most 4 faculty members. A faculty can teach no classes to maximum 3 classes, while a section can be taught by 1 or 2 faculty members. So this is a many-to-many relationship. Some tools use the concept of weak entity. Weak entities depend on other entities for its existence. Example, a student enrolls in a section and receives a grade. The grade can be an entity that depends on the existence of the student and section entities. A weak entity is represented by a rectangle with double lines. In recursive relationship, an entity has a relationship to itself. A common example is that an employee of an organization has a supervisor who is also an employee of that organization. Therefore, employee is an entity which is related to it. ER modeling introduced in 1976, there has been no dearth of extended ER models. There are numerous new constructs that most commercial packages completely ignore. However, many tools referred to as CASE, computer-aided software engineering tools, support the notion of superclass, superentity, and subclasses, subentities. An entity may be a collection of many subclasses. A subclass is an entity and inherits all attributes of its parent. Summary. Now in the end, let us summarize what we have learned in this lecture. The existence of an entity in a relationship is defined as either mandatory or optional. Associative entities are entities used to associate 2 or more entities in order to reconcile a many-to-many relationship. A relationship is one instance in a relationship set. Peter Chen in 1976 first proposed modeling databases using a graphical technique that humans can relate to easily. Humans can easily perceive entities and their characteristics in the real world and represent any relationship to each other. An ER scheme may define certain constraints to which the contents of a database must conform.